Previous to today's lesson, you have always used what's called an XY Cartesian coordinate plane, right? Where the X's are listed horizontally and the Y's are listed vertically, and it looks like a square or rectangular grid. If you think back to some of the verbiage I've used in this class, a lot of the multiple choice questions have always said that the point was plotted in the XY plane. And probably you just read straight over that because you're like, sure, everything's plotted in the XY plane. Until today. This is why you have to specify in the AP pre-cal problems whether we're using a rectangular coordinate system or now what you're going to learn about today called the polar coordinate system. It's a completely different way to graph coordinate points. Are you ready? Yeah, that's the spirit. Let's go ahead and highlight this word, the polar coordinate system, so you know what I'm talking about. This is a different system of graphing points. It is based on a grid of circles centered at the origin and lies centered at the origin and on lines that go through the origin. Polar coordinates, which is our goal today to understand how to use polar coordinates, are defined as the ordered pair r comma theta, such that r represents the radius of the circle on which the point is graphed, and theta represents the measure of the angle and standard position whose terminal ray includes the point. In the polar coordinate system, the same coordinate point can be represented in many ways. And this is why I've been so adamant about you understanding where the angle is around your unit circle. Because we will be using angles in quadrant 1, 2, 3, and 4, and even negative angles to simultaneously plot the same coordinate points. So before we really go anywhere, let's just see what it looks like to plot coordinate points on the polar coordinate system. The first one I'm going to plot is going to be coordinate A, and I'm going to do it in pink. And we're going to plot the coordinate point 4 comma pi over 2. So that's telling me that the radius of the circle I should use is 4, and the angle with which I should plot it is pi over 2. So if I was using my finger to find this, here is the radius 4. And if I go around the circle until I reach pi over 2, that's right here. So the coordinate point 4 comma pi over 2 is right here. That's coordinate point A. Radius 4, we're using the circle with radius 4 and going to the angle pi over 2. Do you follow? Oh, no? Okay. Again, the radius of the circle, so this one right here is radius 1, then radius 2, radius 3, radius 4, radius 5. And then you're staying on that circle as you go around. So basically tells you what ring to use and then how far to go around with your angle. Let's try another one. So if we're plotting B, which is 6 comma pi over 3, that means we're doing radius 6 and then going around the circle a positive pi over 3. So if you know pi over 3, boom, right here, it's even listed for you. So we're plotting this coordinate point at 6 comma pi over 3. 6 comma pi over 3 would be, not right there. It would be here. Do we follow? What if the radius is negative?
You just quit.
You just quit. No. You do actually just start on the other side. So we know, just like with the XY coordinate plane, that this side is positive, radii. So which means we can actually start right here. This one says to start at negative 8. So I'm going to the radius of negative 8, but then it says to travel pi over 4. Here's what I know. I know that pi over 4 from positive 8 is right here. But I'm not starting from positive 8. I'm starting from negative 8. So if I travel pi over 4 units, I'm actually going right here to 5 pi over 4. So negative 8 comma 5 pi over 4, or comma pi over 4 is the same thing as 8 5 pi over 4. This one is split into 12s. Our unit circle is only split into 6s. It depends on how they draw the graph. They can use different. This is probably the smallest increment you would use is 12s because it's half of this pi over 6s. But I'm going to say what I said again because I don't think I made enough of an emphasis. We just graphed negative 8 comma pi over 4. However, I could still get to this coordinate point if the coordinate point was positive 8 comma 5 pi over 4. So there's more than one way to go to every dot on a polar coordinate. That is unlike the XY coordinate system where there's only one address for each coordinate point. This has multiple addresses. Let's try one more with me, and then you're going to try a few on your own. If we're doing coordinate point D, it's 6 comma negative pi over 3. So with your finger, with your pencil, whatever, we're going to 6. That's a positive 6. And then it's negative pi over 3. Which direction should I travel around if I'm going negative? Should clockwise, which, yes, feels down. Okay, I get what you mean. So then we go from here, and we're only going to move negative pi over 3, which means I end up right here. So 6 comma negative pi over 3 is right here. There is an additional coordinate point that could get me here. Instead of going negative, I could go from 6 and then positive 5 pi over 3. Gets me to the same place. I could also go negative 6 and 2 pi over 3. Those gets me to the same place. So there's more than one way to reach an address on a polar coordinate grid. Okay, maybe do this with pencil and not highlighter, but if you're bold, here's what I'm going to do whenever I get, when I go. I'm going to do F in yellow, and I'm going to do E in orange, which I know are the colors you have left on your tables. Go ahead and try to plot these points, maybe in pencil in case we mess up, but then we'll put color on them in a second.
What's that, orange?
Yes, orange and then yellow, because I think those are the only colors you have left.
I know that if it's like pi, we will move right.
Say again?
If it's pi, we will move.
We will move.
Oh, we will?
Because remember, this is 0. Where's pi? So you're going to go from positive 1 whoop, over to pi. Bless you. Do we want some help now? Okay. If we're trying these, the orange one, point E, said to start at negative 2 and move from there pi over 6 units. So boom, it should be here. So this one would be, I just lost it. There it is. That's E. How did we do? For the last one, if I was wanting to do 1 comma pi, I go to radius 1 and I travel pi units around. So 1 comma pi would be right here. That's F. So we're going to take a short pause. And for B-Day, since you're watching this video, because I'm not going to be here tomorrow, you're going to actually pause the video and go to the other set of slides I have for you and try this activity on your own. But for A-Day, hello, you get me here today. We're going to do this which one does not belong activity with the little spider-looking graphs on the yellow pieces of paper and your Expo marker and eraser. Oh, look, a little polar bear. On this activity, what you're going to do, like this one, is you're going to plot all 4 of these coordinate points. 3 of the coordinate points will be in the same location. 1 of the coordinate points will be in a different location. I want you to figure out which one does not belong. Go ahead and do this right now on the yellow laminated piece of paper with the polar graph on it. I want you to plot all 4 points. 1 of them will not be in the same spot. You're identifying which one does not belong. And so B-Day, you're doing this on your own. So sorry I'm not here. I will answer questions when I come back. So some questions that I'm hearing is the direction of a negative theta. Remember, normal thetas go counterclockwise. So negative thetas go clockwise. But you're always traveling this entire distance. Don't just go to that angle that you see on the graph because we're going the negative version. If you look at the slides, I'll help you with this one. So which one does not belong? Here's where you should have plotted A. Here's where you should have plotted B. Well, boom, there it is. Here's where you should have plotted C. And here's where you should have plotted D.
So I did that.
Which means D is the one that does not belong. Can we try another one?
I knew it.
Okay, great. Again, B-Day, you're doing this on your own. Go ahead and pause the video now because I'm not going to turn on the video again until this activity is done. Pause it. Okay, so we spent some time now plotting these points. You will be asked to do questions like that one. Which one does not belong? That's a very popular multiple choice question for this topic. They won't give you a graph though, so you do need to eventually start to either visualize it or just draw yourself a sketch of a polar graph or like flip through the test to find another one so you can count around it. Anyways, the other thing we're responsible for knowing is how to convert our coordinate points from a rectangular x and y coordinate plane to a polar r comma theta coordinate grid. Okay, there are two formulas or two sets of formulas we now need to memorize. If we're converting from polar, from r comma theta into rectangular, we're going to use the formula from our unit circle. So it's really nothing new. On your unit circle, the question I've been asking you constantly is what are the coordinate points around the unit circle? And you would have said r comma theta. R cosine theta, comma, r sine of theta. That is exactly the formula you're using here to convert from a polar coordinate to a rectangular coordinate. So we can go back and forth between the two graphs. So that's like technically not new. What's new though is the conversion from rectangular into polar. So if we are given x's and y's, we need to make them into r's and thetas. The first part of this is really simple because what does this sort of look like? Does it look familiar to anybody? Yes. What does it look like? It's Pythagorean theorem. X squared plus y squared equal to r squared because it's a triangle with x's and y's in your radius. It's literally Pythagorean theorem. The theta, though, is a little bit challenging. For theta, to find out what the angle is of a rectangular coordinate, you would do the inverse tangent of y over x. This still comes from Pythagorean theorem, but we're not going to derive it. The only problem is you have two sets of equations here that you have to pick. If you are converting and the x value that you're given is a positive number, you use the top. If you're converting and the x value is a negative number, you use the bottom. What's the only difference between the top and the bottom? You either add pi or don't add pi. If your x is negative, you add pi to your answer at the very end. Can we see what this conversion looks like before we ask any questions? This is just a formula chart for you. I'm actually going to erase this. You don't have to. It just looks kind of messy. Okay, this is new formulas for us. Let's convert the following polar coordinates into rectangular. So you're going to use the one you put that cute cloud over. Okay, here's a polar. We want rectangular, which means we want an x and a y. But x is found by doing r times the cosine of pi over 6. So all we have to do is remember what the cosine of pi over 6 is. Okay. We have to remember what the cosine of pi over 6 is. So with the hand trick, what is cosine of pi over 6? Square root of 3 over 2. So this is going to be 3 times square root of 3 over 2. We do a little bit of math, which just means our coordinate point would have 3 square root of 3 over 2 as the x coordinate. We do the same thing for the y coordinate. This would be 3 times the sine of pi over 6. And what is the sine of pi over 6? 1/2. 3 times 1/2 is 3/2, which means the coordinate point converting from polar to rectangular is 3 square root 3 over 2, comma, 3 over 2. Make sense? You have a question? What's up? That's all that it's going to be. So I want you guys already to try B and C. You got it. Convert those two coordinate points to rectangular for me.
So is the x the r?
What?
The first one? First coordinate?
Yes. So remember, polar is always r comma theta.
Oh, I see.
So yeah, go ahead and stop now and try B and C. Does anybody need me to walk through that one? Okay, but I will do C with you just because I feel like there will be some gentle questions. This is 2 times the cosine of 3 pi over 4. And if you think about the unit circle, the cosine of 3 pi over 4 is negative square root 2 over 2. The 2's on the top and bottom are going to cancel. You cannot cancel inside of a square root unless you are multiplying by another square root. So this just becomes negative root 2. The 2 from the numerator, the one outside, and the 2 in the denominator will just simply cancel. You can't multiply a regular number into a square root unless it is also square rooted. For y, we would do 2 times the sine of 3 pi over 4. And the sine of 3 pi over 4 is positive root 2 over 2. 2 on top and bottom cancel, leaving just square root of 2, which means this coordinate point is negative square root 2, comma, square root 2. How'd we do? Now that we've mastered converting from polar to rectangular, which again is just the formula from your unit circle, r cosine theta, r sine theta, easy, we do now have to use Pythagorean theorem to convert rectangular to polar. This is your x and your y, which means we are trying to get r and theta. R is easy because it's just Pythagorean theorem. It's going to be the x value squared plus the y value squared. So 3 squared is 9, negative 3 squared is 9, 9 plus 9 is 18, and then we do need to reduce or simplify that radical. So if you were wanting to show work, you would break the number 18 down with a little factor tree and look for pairs. It is divisible by 9, and 9 is a perfect square, so we can factor out the square root of 9, which is 3, and I have a leftover 2. If you're like, whoa, what just happened? Here's what happened. This is 2 times 9. This is 3 times 3. The pair of 3's pops out. The 2 stays in. Okay, so we have our r value. Now we need theta. The formula for theta says that we will do the inverse tangent of y over x. Do I need to add pi for this problem? Is my x value positive or negative? Positive. So we're good. We don't have to add pi. We only add pi if the x value is negative. So, okay, well, somebody has this quiz trade card because I made sure it was out and about today. What is the inverse tangent of negative 3 over 3? Well, first of all, what is negative 3 over 3? Negative 1, right? What is the inverse tangent of negative 1? Remember, tangent and when we're actually doing inverse tangent, we can only go into quadrant 1 and quadrant 4, and we can only get to quadrant 4 using negative angles. This is truly inverse trig, so not think about the whole unit circle. This is the restricted one. So we will write down negative pi over 4, which means the coordinate point in polar is 3 square root of 2, comma, negative pi over 4. Yes, so the tangent, inverse, sine, and inverse cosine are truly the ones that are restricted. Actual inverse trig. Let's do another one together. You'll try the last one on your own. The coordinate point in rectangular is negative 3 and then square root 3. So that means to find r, we're doing negative 3 squared plus square root 3 squared. Well, negative 3 squared is 9. What is square root 3 squared? 3, which means I get square root of 12. And if we break that down using a tree, it's 2 and 6. 6 is 2 and 3. So I have a pair of 2's and a leftover 3, which means this actually simplifies down to 2 square root 3. You can show the tree if you need to see it visually. Do y'all know what I'm talking about when I say tree? Yeah. Okay. To find theta, we're going to do the inverse tangent of y divided by x. Do I need to put plus pi at the end of this? Yes. Why again do I put plus pi? What's negative? The x coordinate is negative. Okay. So inverse tangent of square root of 3 over 3. This is also on somebody's quiz trade card. What is it? Negative pi over 6. So this is negative pi over 6 that I then have to add pi to. When I'm adding fractions, what do they have to have? Which means I can rewrite pi as 6 pi over 6, yes? So what is negative 1 pi over 6 plus 6 pi over 6? Well, but one of them's negative. 5 pi over 6, which means my coordinate point is 2 square root 3 comma 5 pi over 6. You are so right. You are doing the next one on your own. So go ahead and pause and do this next one on your own. You got it. Yes. Yes. For this last one, if we're finding r, we use Pythagorean theorem. This is negative 4 squared plus negative 4 square root 3 squared. So the first one, pretty obvious, is 16. But then when you're squaring a rational term that has both a irrational term, a rational and irrational part, you do them separately. So negative 4 squared is 16. Square root 3 squared is 3. So 16 times 3 is 48. When you add those two numbers together, you get 64, which, 8. That's nice. To find theta, we would set up the equation inverse tangent of y over x. Do I need to put plus pi? Yes, because what is negative? The x-coordinate. If the x-coordinate is negative, I don't care about the y for this. If the x-coordinate is negative, you add pi. Okay, well, I noticed that these negative 4's cancel out. So this question is really just asking, what is the inverse tangent of square root 3? And that's pi over 3. But if we add pi, that's like we're adding 3 over 3. So 1 pi over 3 plus 3 pi over 3 is 4 pi over 3. So our coordinate point, 8 comma 4 pi over 3. I heard a question, but I didn't answer it. Did you figure out your answer? Okay. Questions, comments, concerns about converting between polar and rectangular?
A plus pi.
So far today, we have graphed polar and converted polar to rectangular and vice versa. Those are the first two skills. Say back. On the back, we can also represent complex numbers, which are the numbers that have a real part and an imaginary part. We can represent these on rectangular coordinates, which is what you've done before, and on polar coordinates. A complex number can be understood as a point in the complex plane and can be determined using its coordinates either rectangularly or polarly. That's not a word, you get it. For rectangular coordinates, this is what we're used to. You have a real part and an imaginary part, and the a and the b straight up come from the x and the y. So a comma b or x comma y creates your rectangular coordinate. For polar coordinates, r comma theta switch to the complex number r cosine theta plus I times r sine of theta, which kind of makes sense because this is x coordinate, x equal to r cosine theta, same spot, and y, which is multiplied by I, is r sine of theta. So our job here is to convert or express complex numbers in either form. So here's what I have in this first problem. It says express the complex number negative 3 minus 3 square root 3i in polar coordinate form. So what I want to do is I want to look at this number and figure out the a and the b, and voila, I figured out the a and the b. The b is always next to the imaginary number, which is square root of negative 1, fun fact. Okay, so if that's the case, that means my regular rectangular coordinate would be negative 3 comma negative 3 square root 3. That's the a and the b that they gave me. So we can use the formulas from the page we just did to convert these numbers into its polar form, which means we need to figure out what r is equal to, and we need to figure out what theta is equal to. Same formulas from before. We use Pythagorean theorem. So negative 3 squared is 9. Negative 3 square root 3 squared. Negative 3 squared is 9. Square root 3 squared is 3. 9 times 3 is 27. Add those numbers together. We end up getting 6. That's nice. For theta, we use the same formula from the front page. Inverse tangent of y over x. Do I need to add plus pi? Yes, because what is negative again? The x coordinate. Okay, well those 3's cancel out. Just like before, I'm doing the inverse tangent of square root 3. Who has that quiz trade card? What is the inverse tangent of positive square root 3?
Square root pi over 3.
Pi over 3, but then we're going to add pi to it, which is like adding 3 pi over 3. So it's 4 pi over 3 again. All right. So when we write the complex number with polar coordinates, we literally just fill in the formula from above, which would mean we are writing 6 cosine of 4 pi over 3 plus I times the times r, let me write it correctly, times the sine of 4 pi over 3. And that's it. I is always the square root of -1. But this allows us to express the complex number not only on the rectangular coordinate system, which you are eventually in college going to learn how to graph imaginary numbers, and polarly we can graph them. That's not a word, Miss Quigley. Polarly is not a word, but you get what I mean. Can I let you guys try one? I'm going to get you started, but you're also going to try number 5. For number 5, it says express the complex number 1 plus I in the same format. But if I write 1 plus I, this is A. What's B?
0.
1, which means the coordinate point I'm working with is 1, 1. You take it from here. That's the rectangular coordinate. I want you to create the polar coordinate and then express this number in polar form. What's up?
You did the easy part.
I know. You can do the next part.
Okay, we don't need you.
Whoa, okay. This is r equal to 1 squared plus 1 squared. Yes, that really should be in parentheses. Let me fix. 1 squared plus 1 squared, which is 1 plus 1, which is square root 2. We don't know the square root of 2, so we leave it. That is a simplified radical form. Theta would be the inverse tangent of 1 over 1, which is like the inverse tangent of 1. Oh, wait, did I need to add pi here? No, why not? What's positive? X. Very cool. All right, inverse tangent of 1 is pi over 4. So when we put it all together in polar form, this would be square root 2 cosine of pi over 4, close parentheses, plus I times square root 2 sine of pi over 4. How'd we do?
You told me the square root of 2 was 1. I was like,
Right, we're gonna, in this last example, write the polar and rectangular coordinate points of the complex number shown on the graph. So we're starting with needing to read the polar graph. So question, if I was asking you what this location was, what radius are we at? 4. What angle are we at? Cool, so the polar coordinate is 4 comma pi over 6. And just to make sure you understand, we're gonna put a little arrow and say, that's polar. Which again, remember, that means this is r, this is theta. If we're trying to switch it into rectangular, so we know the rectangular coordinates, this is when we will use x equal to r cosine of theta, which is 4 times square root 3 over 2, which, yes, reduces to 2 square root 3. And y equal to 4 times the sine of pi over 6, which is 4 times 1/2, which is 2. We then have our rectangular coordinates, which is 2 square root 3, comma 2. That's the rectangular.
Oh, so we should find.
And if we wanted to write this as a complex number in either format, the complex number would either be 2 square root 3 plus 2i, that's the rectangular version, or r, 4 cosine of pi over 6, plus I times 4 cosine, just kidding, sine of pi over 6. That's the complex number represented both ways. So we are able, with either given the polar or rectangular, we are able to go back and forth into either type.
So you leave it as pi over 6?
For the cosine of pi over 6, everything I've seen of these, that leave it with the sines and the cosines there. We do know what the numbers are, but we would leave it.